Today we will look at the three broad categories of artificial intelligence or AI. So the three kinds of AI, we will describe each of them in some amount of detail and their applications. The first kind of AI is called artificial narrow intelligence, or also known as ANI. The second kind is known as artificial general intelligence, or AGI. Then the third of this is called artificial superintelligence, or ASI. So let's come to each one of them and explore in detail. In terms of ANI, artificial narrow intelligence, the basic idea is that given a narrow task, you have an intelligent program or a machine which is able to perform the task with very high performance and with very high accuracy levels, as close to a human being or better than a human being. But the key aspect is we're talking about a narrow task. So what could be examples of a narrow task? A narrow task would be playing a very specific game, like say chess. Or a narrow task would be, say, drive a specific Honda model car. So what we're talking about is a very specific narrow human task being done by a very intelligent program which is able to give performance as close to or better than a human. So we have numerous examples today of computers with AI programs performing as close or better than human beings in these narrow tasks. So let's take example. So we have seen how a AI program like Watson from IBM defeated the world Jeopardy champion, which is a general knowledge quiz competition, right? But that is a very narrow domain of general knowledge. So we have a very special program which is able to perform with high efficiency, much better than a human champion. Today we have highly efficient game programs which are AI enabled, which can take a very specific narrow game like chess or Go or even poker in the latest edition, which can defeat the human champions. What's the deficiency of ANI? The ANI deficiency is you take a program which is running a chess program very well, defeated the world champion in chess, and you go and fit the same program to play, suppose, Chinese checkers or to play Go, and it will not work with the same efficiency. That's where ANI falls apart, in the sense that this program is programmed to perform very narrow tasks. And that's where we have the expectation set up by AGI, or artificial general intelligence. Where, let's take a human being. Suppose we learn driving, right? We normally work, suppose, towards learning driving in one part of the world, like India, which is right-handed. And then we go to a work environment which is like US, where it's left-handed driving. It doesn't take for us forever to change to the driving habits and get acclimatized to the new habits. But inherent aspect of driving which we have learned as a skill is already imbibed by us. That's where the expectations of artificial general intelligence is, without explicit reprogramming or explicit fine-tuning, can a program which is being developed for playing chess reorient itself to perform equally well in a new game like Go? Same thing, suppose you have a driverless car program which runs very specifically on Honda specific model. Can it work on all generic Honda models, or for that matter any other kind of car like Tesla? So that is where artificial general intelligence expectation is, that we can create a general purpose AI program, also sometimes known as strong AI, which can enable creation of a generic intelligent piece of code or software and hardware, which can not only work in one specific circumstance, but can work in generic circumstances by mild variation in which it can figure out with respect to the external environment. And such kind of general intelligence is very hard to get. As we speak today, we are really getting very high levels of performance in ANI, but AGI is still to be achieved, and it is probably a couple of decades away. Though we're seeing some tenets of it in recent, reinforcement learning approaches like in AlphaGo, Zero, etc., where we see that programs have tried to accustom themselves to different games by using the same generic principles. But AGI as a vision is still some decades away. Then comes the more complex version where we're talking about all the doomsday scenarios painted by all the, all the paranoia going around AI, which is what we call as artificial superintelligence. The idea in artificial superintelligence is that is it possible to create a software or a hardware program endowed with AI which can beat humans and outsmart humans potentially, and leading to a scenario where we may leave a world which has very little control in the hands of human beings, but robots and AI-enabled agents taking over the world. But the point is, ASI is, I think, more like a paranoia for now, and at least from the practitioners in the field, it's very evident that there is very little truth in the element of AI agents outsmarting human beings and any kind of paranoia around AI. So what we can say is ASI, which is artificial superintelligence, is way off the radar, and AGI is a couple of decades off the radar, and ANI is something we are excelling in, and today we are producing more and more specialized ANI programs, some for playing games, some for playing specific driverless car, or some people are using it for specific diseases like, for example, breast cancer or any kind of cancer. So we are here to work out in the realm of ANI, where we will derive business advantage and competitive advantage by developing specific ANI programs. So let that be the focus, and let's concentrate on building more and more flavors of ANI for specific business use cases.